Holy macaroni!
Last week we looked at how 2D shapes make up a subject. This week we're shape-shifting into another dimension and we're going to be drawing 3D shapes in 1, 2 and 3 point perspective. Stay tuned. Yes mate, thanks for tuning in. I'm Renato, and as always this show is powered by conceptstart.net, the place where you can go for some instant art inspiration. Now welcome to the second episode in the Drawing Fundamentals series. We're going to be going from 2D shapes and learning to draw in perspective in 3D space. We're shape-shifting into another dimension. So this topic's probably alien to some of you. I'll get the bad jokes out of the way first because we're going to need a lot of focus. This is quite a tricky subject and it's quite technical, but we need to learn it. It's a core fundamental principle for any drawing that we do. So, the appearance of an object is always relative to the perspective or viewing angle of the observer. But what does perspective exactly mean? The art of representing three-dimensional objects on a two-dimensional surface so as to give the right impression of their height, width, depth, and position in relation to each other. So basically we need to make sure the perspective is right, because every time you create a drawing it's a viewing angle or a lens by which the viewer is observing through, and they match it against their own version of reality and their own understanding, so they know what's right, what's wrong. They can pick out instantly flaws in your drawing. So we need to get perspective spot on, otherwise things break down and it just breaks that magic. So it needs to look accurate, it needs to be on point, unless you're some kind of abstract artist, and yeah, it doesn't really matter at all then. But especially in the entertainment industry, as illustrators, as concept artists, making sure perspective is accurate, people will tell you that that's just one of the core fundamentals you cannot afford to get wrong. Categorically, don't happen, no. So there's two main things you need to remember in perspective. So you've got the horizon line, which simply represents the eye view level of the person observing, or the camera or the lens by which you're viewing down. And then you've got the vanishing points, which basically is where the receding parallel lines appear to converge. So let's start with a basic type of perspective. I need to think of an image or something which can sum it up quite simply.
Help me! Are you helping me or are you going on and on? Did anyone see the movie Tron?
Prepare to transport to light cycle grid.
Wow.
Okay, so on this image that we see now, taken from Tron, thought it would be a good example. We have a single vanishing point and a single horizon line. Now before I go into it, I'd like for you to see if you can actually establish where the horizon line is and where the vanishing point is. Pause it now, I'll give you a clue. The horizon is somewhere in the black, so is the vanishing point. It's kind of a clue, I guess, kind of gives you some narrow boundary. And pause. Did you get it? Let me show you where it is. There, ladies, gents and friends and foes, is the horizon line. This is a 1 point perspective right here. Tron it up. So let's move on and start doing our own shapes, shall we? Boosh! Get on with the 1 point perspective. We're going to start from the proper order now, which is establishing the horizon line first. So yeah, we did it a bit backwards, but I just wanted to squeeze a bit of Tron in there. I've created a generator which generates tasks and gives certain coordinates and plots for where to place the horizon line, where to place the vanishing points, and I've provided also a PSD grid which you can download and basically correlate the points from the generator and the shapes that it suggests to draw, and you plot the coordinates on the grid. So it's a cool way to basically practice these tasks, practice 1, 2, 3 point perspective by simulating, I don't know, just random coordinates. So now we're going to place the horizon line as suggested by the generator, and then we extend the lines from the edges of the shape so that they converge towards the vanishing points, and then we fill in a line to determine the edge of the visible sides. So now we've got a cube in a scene, and that's it. Now you know perspective. Well done. It's my job done. So 2 point perspective is where we've got 2 vanishing points on the horizon line. Now, I don't know if you noticed, on the cube that I drew, I kind of just estimated where the sides of the cube would be in relation to the viewing angle. Now that's not really a good practice because it's not 100% accurate. We really need to be of a mindset where we're getting things 100% accurate and have a full, thorough understanding of perspective. So what I'm going to introduce now, as well as 2 point perspective, is how to determine measuring points. So this is where it gets a little bit tricky and a little bit complicated, but this kind of brings perspective full circle. That was not intended. That was I didn't mean it. So how do we determine the exact length of the sides of the cube in relation to the viewing angle? So now we need to measure the measuring points, and I'm going to do a quick demonstration now. So first we need to find the horizon lines and vanishing points. Next we place the first vertical edge of the shape on the canvas. We place it down x0 as suggested by the generator. This vertical line determines the distance point. Now we take a right angle square, place one of the sides on vanishing point 1, and then place the other side on vanishing point 2. And then make sure the corner point of the right angle is placed on the distance point. Now to establish the measuring points, we need to connect 2 lines from the vanishing points to the distance point, then overlap the length of each line back across the horizon. The ends of these lines determine our 2 measuring points. Next we need to make sure the viewing angle is no greater than 120 degrees or the shape will look distorted. We then decide what the full length of the first edge will be. We then copy it twice and place them in a mirrored formation at the base of our first edge. The edges of these 2 new lines will then connect to our measuring points. Now we can begin to build up the 3D cube based on the foundation lines established. Extend all of the remaining lines from the edges of the shape towards the vanishing points. Now we have a cube in accurate perspective. Okay, so let's do another demonstration now, following the same steps as before. We're going to start with a different angle, and the main focus of this is to find more complex shapes within the more basic shapes. What I'm also going to do is determine a safety zone and a danger zone. See, anything outside of these 120 degree angles effectively distort the cube, so it's important that we make sure we draw within these boundaries. So as you can see, what I'm doing now is I'm drawing shapes within shapes. By using the dimensions of a basic cube, it enables us to determine with more accuracy the shapes of things such as a circle, which is really hard to draw freehand. Now what you want to do is make sure that you're always using the middle points and subdividing the basic shape until you feel comfortable to place the lines for the more complicated shape. by finding the middle point, we're able to determine where exactly the shape will fit in 3D space. Now this principle will serve throughout more technical drawings such as landscapes and vehicles and props, things that are quite mechanical and have more complicated shapes that are required to be drawn in perspective.
Ow! Watch it, Coney! Oops.
So now we've got the hardest bits out the way. If you understand that off the bat, then all power to you. It's great that you've understood it so quick. It is a very tricky thing to get your head around, but it's a methodical process. It's just a formula, principles and methods. That's essentially all we need to know to get the finished result. Now we're going to do 3-point perspective. It's not that much more different from 2-point perspective. The main difference is that the third point is not placed on the horizon line. It's placed either further up or further down somewhere, and it's usually a bit more central within the center line. It's used a lot in comic books to make grand scenes and epic scenes, you know, when you get high heights and that, and you got Superman flying around on tall buildings and stuff like that. This is a good book, you should buy it. Okay, then let's do the demonstration. Okay, so what we're going to do is utilize the 2-point perspective shape that we created previously. Once we've established the third point perspective, we project from the vanishing point through the corners of the base of the basic shape, and as they extend out, we are able to then get the coordinates for the top edges and accurately portray how they protrude outwards. So this cube is now a cube based in the 3-point perspective environment. If you're struggling to determine where the more complicated shape can fit into the simple shape, then it's always an act of subdivision. You keep subdividing and halving the side face of the cube until you've got accurate tracing lines to be able to reflect the more complicated shape. Now here what we're doing is using the corners again and extending them towards the vanishing points, and through this build up we can determine where our correct lines will be placed. And that's essentially 3-point perspective, suitable for artists.
Take that, you lousy dimension!
Oh, there's so much I don't know about astrophysics. I wish I read that book by that wheelchair guy.
Okay, so before we wrap up, there's one more piece of really important information that I think you need to learn, which is foreshortening in perspective. And so how do we establish accurately the distances in perspective as things recede of the same nature? So for example, windows on a block of flats that are all equal in width. When they're seen in perspective from a certain angle, you'll see that they recede down to a certain point, and each window column gets shorter and shorter and shorter and shorter, and there's a way in which we can actually determine the exact measurements that occur within this pattern. So let me just demonstrate quickly here. Okay, so what we need to do first is establish our cube. We'll use the one from the previous demonstration. Basically, you need to find the middle point from the front facing edge that we want to extend. We do this by drawing diagonal lines from corner to corner. Then through the X point, we draw a line right through it from the vanishing point to the middle of the front facing edge. From here, we keep subdividing down the central line towards the vanishing point, going from the top right corner through the intersection, then vertically upward to get the new height, then back down to the bottom right corner to create another new intersection. And you can keep repeating the process as far as you like. We then connect all of the edges to both vanishing points. Finally, we overlay our construction lines with the newly established foreshortened edges. We've successfully shapeshifted the realms of 2D and fully transcended our understanding of how to take 2D objects and translate them into a 3D space in perspective. So whenever you're setting up an image or a scene or a character, always come back to these principles. They'll serve as the foundation for more accurate, believable and engaging drawings. Make sure all the relationships with all the objects appear in the right place as they would do in the frame of mind of reality as someone would perceive it in real life. So we need to make sure all the relationships between the objects are in perspective from the founding vanishing point through as it stems out. Otherwise the image is just going to break down and look flat. You can't afford to have glitches and errors in your portfolio in perspective. These core fundamentals, which I'm trying to demonstrate throughout the whole course and practice myself, basically everything I've done wrong, I'm kind of trying to put right and package it up for everyone to follow correctly. So keep practicing these fundamental principles and be sure to check out the generator that's provided on the website. If you want to create more complex shapes, start off with the basic geometric shapes first, find the more complex geometric forms and patterns within them. I think we'd better wrap up now. We're out of the fourth dimension. Out of time.
Come on, man.
Had to drop that one in, sorry. Until the next episode, which is on understanding ellipsis, light and shadow, how to shade objects. That's all from me. Thanks for watching, and as always, I will see you later.